How are we doing? So we got Trace in the chat. I'm almost done with my lunch. Just relaxing for a little bit here. Sorry about that 3-minute, 4-minute start. Could we go over 2C interpretations of the data for homework 474, number 9? Number 9. Let's do this. 2C. Let me look at 2C. I don't want to give away too much. Let's talk about a little 2C. So is this, what class would the naive model predict? What is the naive model's accuracy on the training and the holdout? Are you talking about that one? Lunch is money important. I do agree. Try to take a little time, make a little lunch. Took a little moment longer to get just, I don't know. I've had a lot more smoothies lately. I don't know. It's just nice and easy. It's got bananas, peanut butter in it, almond milk. Good stuff. Excellent. Healthy choice right there. The naive model predicts the one that is more correct. Well, not that is more correct, is majority. The naive model predicts more majority. So you should be getting numbers like 65.65, about 65.649. So that is what you're talking about. Good question right there, Trace. So does this answer right here, the naive model, whenever you look at, like, let's say you were to go to campus and you were to predict if people are students or not students. If you saw a random person on campus, would you predict that they are a student or not a student? What would you predict if you saw a random person on campus? Do you think they're a student, just random person, didn't tell you anything about them? They're just a student or not a student? What would you predict? Which chapters, Nicole, which class are you talking about specifically? A student, yeah. Tell me which class specifically, and then I can go into that. I predict they are a student. But you're thinking about an X variable there. If you say depends on the age, that would no longer be the naive model because that's taking, a good answer right there. That would be using information on them on their X variable. Let me reset MuBot here. That would be using an X variable. BS474, yes. BS474 is going to start with market basket analysis and then go all the way through with market basket analysis. So you will see things like lift, support, and we will basically be doing that. Market basket, clustering, then you go into data mining right there. So good question, Nicole. So the naive would predict no for us. How do you calculate the accuracy? So when you look at the naive model right here, and we look at how it works, and so it is going to predict no. So what would be the accuracy of the naive model? So I think you're onto it, Trace. What would be the accuracy? You're welcome, Nicole. Great questions. We're just starting up. Boom, we got it. Keep asking those questions. We're just here on the question screen right now. So then how would you predict the accuracy of the naive model? So the naive model will predict everybody's the majority class. So if we were to go to campus and 95% of people are students on campus, what would be the accuracy of the naive model? So we're going to predict if someone's a student or not a student. Well, everyone would be predicted the majority level. Is this making sense, Trace, right here? Like, if 95% of people on campus are students, then we would predict everyone's a student, and then we would be right 95% of the time. We're not using any additional information. We're just saying, let's look at how often the majority class occurs, and then everyone would be the majority class. Because we're just saying, most people are no, so, well, then let's just say everybody's a no. So if you're looking at the data right, you're making sense. That's what I want to hear. I don't want to quite show the answer, or like, if you're hearing this talk right here, then you should be like, okay, most things are no, so everything's no. And then you would be right 65% of the time, as Trace is pointing out right here. So we're just looking at what is the natural distribution of the Y variable. And the naive model just says, well, what are most Y observations? Most are no, so everything's a no, and then you'd be right 65% of the time, and you would misclassify 35% of the time, which is the complement of the naive, stat 201 right there. What other questions are there? Great question to start out, Trace. Great question, Nicole. Meanwhile, why are you not giving out points? Makes much more sense. That's what I want to hear. Great job, Mubot, giving out some points in the chat. Put on a little chill music. I need to fix my sound effects screen. I've got a whole sound effects screen with sound effects, which just don't work properly. Like, here, check it out. You ready? It's way too low. That's the Smash Bros. It just doesn't, you can't even hear that. 3D, homework 9. I don't know to put in for the Y. So 3D, going down here to 3D. Homework 9 or homework, are you talking about question 2 or question, because there might be a numbering issue here. Which one are you talking about specifically? Homework 9, question 2D? Are you talking about, although the arguments could be made for both metrics, explain why the bank would have Which one specifically? Let me go grab homework 9. And if you can put a little more of the question in there, we'll take a look at it right here. Hey, Brian, can we go over the ARIMA models? Yeah, for 475, let's do that here after this. You got it. I'm going to pull open the homework. And let me get everything situated right here. And let's go grab homework 9. And let's go take a look at homework 9, 474. I'm getting the homework open. And then we'll talk about some ARIMA next. Okay, let's get homework 9 open for 474. And fit vanilla. So in this one, you are predicting whether or not people will... Is it purchase? It's purchase, right? I'm getting the homework open right now, just trying to think through in my head. It's purchasing or not purchasing, right? So fit the vanilla. So, and we did some of that today. We didn't fit a vanilla one today. Vanilla will not have a tuning grid. So fit the vanilla for E right here. Yep. Okay, let's go take a look here on the main screen. Okay, so fitting the vanilla right here, the Y variable of interest, and we do have a lot of this filled out for you. Remember, today we did the model right here. So you can see the form of the model. We're doing some control of the randomness right here with the set seed. But right here is the Y variable of interest. So the Y variable of interest will be the Y variable you are predicting. This is where your formula format goes. Your Y tilde X comma data equals. Sometimes I don't like giving all these parts of the code. It helps sometimes to write it out. Y tilde X comma data equals, comma method, GLM, and preproc center scale. So these are the things we need to fill out right here. And the Y variable of interest will be the response, I believe, or let me double check. The Y variable of interest is going to be... I believe we're predicting response, right? Let's go look at the data. Go. And account. We are predicting purchase. We are predicting purchase, whether or not someone makes a purchase. So we are predicting purchase. There it is right there. Purchase in question 2 at the very start. Purchase, exactly, Zaid. Great job, yep. Make sure to spell it correctly. You can see how it is spelled right here. You should be able to find it. Y tilde X comma data equals. Is that making sense? So the Y variable response, but is not running. Send it to me via Discord. You might send it over Discord. I might take a look. I can look at it in the in-between screens. Send it to me on Discord, your RMD, and I'll look at it between the screens, and I'll see what's going on. I'll make a comment on it. But that's got it right there. So send that to me. Or, you know what? Let's go do that right now here while we're doing this. Let's go take a look. Can you send me your files, Aid? Let me take a look at that. I thought I played more music. Let's go take a look at this code right here and see what's going on with it. Okay. Let me hop over here. And send me that code and I will take a look. I'll see what is happening here and I'll try to fix it up. It might be that your training is miscreated. One thing you often want to look at, I don't have the screen showing right now. I'll show it over here. You want to look to see if your train is properly created. If your train data is not properly created, it won't run. You want to make sure you have the right amount of observations, and this goes to how you created the train data. So make sure you have the train properly created. If you want to send me that on Discord, I'll take a look and I'll try to fix it up. Then we'll talk about some ARIMA models. Talk about some auto ARIMA, some ARIMA, some differencing. Error in NA default, purchase, missing values. It sounds like the train is not properly made. Send me the RMD and I'll take a look. It sounds like there's an issue with the train data. If you send it to me here, I'll take a look. Just go to Discord, use the plus icon, and send the file via Discord. There should be a plus icon in the bottom left corner if you personal message, and you can just drop the file in there, and I'll load it up here on the other screen, and I'll take a look, and I should be able to fix it up. We'll take a look at that. Then we'll talk about some ARIMA. If you're here for 201, 474, 475, feel free to ask questions. We're looking at ARIMAs next. Just did awesome, Zaid. Let's go take a look at that. Okay. There we go. Okay. Pulling up the file right here. And let me go down to question 2. The big thing to look at. Okay, so you don't have your GLM Nick grid. Okay. I don't see the variables in here. Okay, wait. Here you have your logistic regression in D. One thing I like to do is I always like to space it out so I can see what's going on. Just gets all kind of put together. Are you talking about for D or for E? Because I don't see any code for E right now. Okay, this worked. I don't see any code for E yet. I don't know if you sent your most recent file, but I don't see any code for E right now. So let me look in the chat. You did in 1D. It's working in 1D. It's giving the result in 1D. Do this. Run all your code above. The question is E, but I did the 1D. And so right here, yeah, I see it. It's correct. Is the chunk called that? Oh, it is called the 3D. It is called the 3D chunk. Everything's confusing. It is running. Run all your code above. Hey, let me rerun. I'm going to delete everything out of my global environment. Run all your code above right here. And then, yeah, everything's working. Clear out everything you have. You might have just made a change. You know what it might be? I think I know what it is. Are you running the code we did today in class? Did you do the examples today in class? Because you might have that saved as your train in your global environment. So run all the chunks above. Let me show you where that button's at. So I'm going to go back here. Let me delete your homework. Don't save. There we go. Okay, let's go back to the main screen. Run all chunks above and then run current chunk. So run your chunks above and then run the current chunk right here. So you want to click this button that runs all chunks above. That'll run all your data above. Like we run this, it runs all the chunks above, and then run the current chunk where you're trying to run it. So does that fix it right there? Because I think you have a different train saved up there. I think you're using a different train from a different data set. Try that, because when I did it, it worked. Because I think you might have done some of the examples in class. Great job following along in class. Let's throw some 50 points of that. Following along in class, I think you were doing a great job right there. And I think you had a different train data set saved. Does that make sense? I think that's possibly what happened. It's possibly what happened. Is it working now or not working? My lunch is almost done. My hope and my guess is that it's now working. I'm going to knock something over. Is it working? We'll check in. We'll do some Arimas now. Main screen. Back on the main screen. Time for some Arimas. Chill music right here. Yeah, we never listen to this song enough. Let's listen to it. Let's go here and work through a little bit of Arimas. Let's hop here, talk some 475, and do a little 475 review. I'll get back to you on Discord. Awesome. Yeah, I think it's working. Run all the chunks above. It worked for me. We might have to look over it, but it should be working. Looks like it's working. You're welcome. Yeah, I think just run all chunks above. I can give a different train data set saved. If you click your train data set, you might not see purchase in it. You might be using a different train data set that doesn't have purchase, so it's like it can't even run it, which is all right, but run all chunks above. 475, talking about some ARIMA models right here. Now, there's some confusion, not like bad confusion, but one, we need a time series data set. Let's go to the ALSPEAR data set. We got so many, look at all these ALS data sets we have. One thing we run into, let's go to the forecast package. I don't think we have forecast up. Yep. Well, got masking. You see that something's masked from Fable. So that means this right here, Fable Tools, has in it an accuracy measure for accuracies of models. And these are F table rules. So F table rules and all this good stuff right here. But also we have inside of here, the forecast package has inside of it, there's too many four. Forecast also has accuracy. So when you see something is masked down here, it's basically saying it's on top of it. Not really a good thing. It's just two people want to call the function the same thing. So we're getting this masking with our forecast function and the masking with the accuracy. So now we have some overlap between the functions, and we might have to call them by calling the packages. What happens when you get a bunch of packages on your computer? So we have the forecast package up. Let's go to data. There's the forecast data. We got here the Taylor series. Got here the gold, US daily morning gold prices. Australian gas production, monthly. Cool. So let's look at some monthly gas production in Australia. And when we look at an ARIMA right here, there are 3 things to look at in an ARIMA. Can anyone tell me one of the components of an ARIMA? When you look at an ARIMA model, what are the components? And look at all the different ARIMAs we got. We got Fable, we got ARIMA. I prefer to use this one right here. This is the one I use most often. They all have different options by how they're going to use information criteria right there. The order by which we're going to do things. This one has constraints for the orders. The smaller numbers down here are going to be your non-seasonal impacts, and your capital letters are going to be the seasonal impacts. And then if you look right here, I think it's just better, nicely put right here, where these are the non-seasonal impacts right here, and these are the seasonal impacts. So looking through here, what are these 3 numbers accounting for? Major portion of your test. What are these 3 numbers accounting for when you look at an ARIMA right here? I do like the way this code is sectioned. It's the one I've been using. I just think it's really nice to use. What are those 3 numbers right there? Hint, it goes with ARIMA. So what are these 3 numbers right here going to be? We won't use the auto ARIMA yet. But what are these 3 numbers here going to be? Any ideas on these 3 numbers? And we have a time series object. So we've got this gas data in our glow environment. If you look at the gas data right here, I believe it's monthly as it said, and you can see this right here. So we could extract out like the month, all this good stuff right here. If you go to the frequency of the gas data, you should be able to go to frequency and go to gas data. It has a frequency of 12. I think we get months out of it. Lubridate. Will it get month? That's what Lubridate does. Lubridate does not like it. It's not a Lubridate object. We should have here instead of forecast, month days. Nope, that's not what we want. So what is an ARIMA doing for us? Big questions right here for 475. What is an ARIMA doing for us? What is the point of these 3 numbers right here? So we've gone over these types of models, and we've gone over this type of idea. This is not really a model right here. So this one is the non-model one. It's the I. But the other ones are pretty clear when you look at the ARMA portion of it. There are ARMA models. You can do an ARMA, but you can quickly make it an ARIMA model by including this one right here. Any idea for any one of these numbers? It's not going to change much. What is any one of these numbers going to be with this information right here with ARIMA? So that's what this is, an acronym right here for autoregressive integrated moving average. So the autoregressive portion is going to use a phi kind of tuning parameter to allow us to use the past points and look at the correlation. So we're going to kind of control for autocorrelation right here, the autoregressive, kind of the correlation on previous points. Auto meaning self, regressive, sort of like correlation on previous points. So the correlation between previous points is controlled by the autoregressive part of this. The integrated right here is going to be the differencing we are doing, and the higher the differencing order, it's going to be more difference. Not kind of like a filter, but the way in which we're doing it, it's almost like tuning parameters in 474, where we're like, let's turn the knobs these way. Like you're just turning up a knob, turning down a knob, like a certain amount of autoregressive, a certain amount of differencing. And you're saying here we're just doing no differencing. We should just be doing white noise right here. So this should be a white noise. If we do an ARIMA sim with this, we should get a white noise pattern. And then the 0 over here is going to be the moving average, which is the way in which we are using the past errors to predict the current. So if we go back 1 past error, this would be an MA1. If we go back 2 past errors, it'd be an MA2. We can go back 3, 4, but because it's a little crazy when you go back that far. We might actually need to be looking at a seasonal difference right here. So this is a season 12 model. It's got 12 seasons because this is monthly data. That's what we mean by the seasonality of it. You can see the frequency right here. Like it cycles through every 12 periods. It goes back to what we see in January and January of the following year. Not exactly back to, but we might see some sort of seasonal pattern to the data. So by looking through the ARIMA model right here, we can do the same exact thing. This ARIMA, I like this ARIMA better. This ARIMA right here, we can see that on the seasonal right here, we have the correlation to the time of last season. So this would ask, if we're doing a monthly data set like we're about to do, this would ask, how is the current January correlated to the previous January? Like maybe we can have some sort of coefficient that tells us how we can better predict this January based on the correlation it would have, positive or negative. Like maybe if we have a good January last year, we're going to be more likely to have a good January this year. Now, this one is the differencing. Like when we look at maybe there's some sort of trend in the seasonality where we're seeing some sort of growth. So maybe we want to difference out that trend and we can remove out, because differencing is going to help us remove a trend in the data so we can get towards a white noise pattern. So if we see some sort of nonlinear pattern in the seasonality, then we can do a differencing on the seasonality right here and we're good to go. And last but not least, we have the MA. So if we're predicting poorly on last year's season, we can use the error on our prediction, which is what the moving average is going to do for us, use the error on last year's prediction to help us predict this year's January. So maybe last year's January is going to help us predict this year's January. But if we do an MA2 on this for seasonality, maybe it's some sort of way that not just last year's error, but the last year before that error. So last year's error and then 2 years ago's error. So the different, or the order by which we use these values would be, do we want to use the correlation between last January, or the correlation between last January and the previous January, or the correlation, gets a little crazy right here, or the correlation between last year's January, last year's January, and last year's January if we go within AR3 model in part of the ARIMA seasonality? Do we want to difference this 1 time, 2 times, 3 times, taking the differences between, we have here a change from this year to this year of 10, so we can just look at the differences instead of the series itself. And last but not least, we have the MA, which says last year we missed by this much. Well, then let's use that information for how much we missed by last year to help us predict this year. Or if we go to an MA2, let's use the information for how much we predict missed by last year and how much we missed by the year before. Use that information as part of the equation to help us predict. And lots of options down here, just so many, like method, all of this good stuff right here, maximum likelihood estimates, lots of good information. Woo! And then we've got some transformations. We have talked about box Cox. There's your box Cox lambda in there. Lots of good stuff, including X variables. We didn't talk so much about that, just not a ton of time. So let's go ahead and use the gas model right here. And let's go here to order equals, let's just throw in nothing on it. Nothing at all. Seasonal. There we go. And let's just see what we'll get. There goes the ARIMA. And let's go here to fit. And let's look at the check residuals on this. Did I call it capital fit? I did. I am surprised that plotted. Oh my gosh. The errors on this are astounding. Now, one thing we need to quickly see right here is there's an answer to an immediate thing I would put in this right away. Actually, there's 2 things I would do to this right away. What 2 things would you suggest to this right away? There's 2 very low-hanging fruits. And one of them can be seen right here. And the other can be seen right here. And I almost think we talked about piecewise today. I could almost see going with a piecewise on this. I am interested to grab today's code and maybe go piecewise on this. I'd be interested to grab today's code and go piecewise. I think a piecewise could come out very well on this. But we should see 2 low-hanging fruit issues. And this is not good. And I do see this here too. There's a 3rd issue. I'm seeing 3 things now, which is rather obvious when you think about what kind of data we're dealing with. What are one of the 3 issues we see and how can we deal with this? So this right here is not the right model. We've left a lot of stuff on the table. Not the right model. Tons of things on the table right here. Any one of the 3 issues that Brian sees Residuals also looking pretty not good behind my head right there. Not good residuals. Who can throw one of the three issues we see right here? One of the three. Need one. I will name all three issues I see. If you can name one of the three you see. Take a moment to think about it. I'll give 30 seconds on the clock right here if people are thinking over what issues do you see on this graphic. Hey, Brian, just dropped in. Sorry about the unrelated, but that's a pipe option right there. The mean isn't 0. You might be right. I think, yeah, we can look at the residuals of the model. We should be able to grab the fit. Let me go grab the fit. Residuals. There's the residuals. Oh, it's actually very close to 0. It's actually very close to 0. Do remember this is... Oh my gosh. Just remember that scientific notation right there. A lot of people forget that. They're like, whoa, that's a big number. It's 2, -2. No, it's scientific notation for a very small number. The big issues, and Sydney, great job right there. 50 points, Sydney. Great answers. The pipe option right there is just passing it through to the next thing. I can show you some pipes here in a second. Like, I'll show you how to like use the piping option. So if you want, I'll cover that next. Could you go over the 2i? Yeah, we could do Sydney's question. And so we'll just talk about this model right here with the ARIMA. Does anyone have any ideas how to improve this ARIMA right now? Or any things wrong with this ARIMA? Anything wrong with this ARIMA that you see? I'll answer the questions. I see 3 things with this ARIMA right now. One of them is kind of coded within this right here. You got it, Sydney. We'll do that next. I'll show you how to use it, the dplyr a little bit, and definitely feel to go over dplyr on DataCamp. Great option right there. And I'll talk about the piping option a little bit here. How to use pipes. Well, how do you think we could fix this right here? I can fix this. I can fix this. And I could fix that issue right there. Those are the 3 issues. Issue number 1, we have non-stationary data right here. It's going with a linear trend. Probably some differencing is going to fix that. Issue number 2, we have heteroscedasticity. You know, we might just slow it down a little bit here. We might not try to fix them all. Let's just go bit by bit, little bits. How are we looking right here? Oh, look at that. Oh, and look at, now we got something different. Difference, yep. And so the I part of the ARIMA right here fixed with the differencing, and ooh, look at this right here. So now let's try a little lambda action. Go lambda on this and see what we get. I think lambda, it should be auto, right? That always confuses me. It is auto. Lambda, wow. Do remember what we're getting from this, how it's changing. Just watch the process right here by which we are making this a much better series, where we had the trend removed by differencing, where we had, I've been looking up material forecasting. Yeah, a lot of people use pipes. It's very common, and I think this will help right here, which I could do this. What I could do right here, watch this. If I want to use a pipe, I can pass this fit into the check residuals. So this might help with seeing this right here, Sydney. If you look at this right here, this should run. And does this make sense? What happened right here is it took the fit and then passed it through to check residuals. So it's just like passing this off into here. Does that make sense what's going on? Like whatever is created right here, because this all is being created at this moment, which I don't even need. Oh, I did something bad. There we go. I don't even need to then save it. A lot of people like that right there. It'll run this way because it'll go through to the next thing right there. Like it'll then take that object, which was created right here. So then I don't even need to run this. Like if I clear this out, running this right here will just pass it through into the check residuals. And so now I'm just taking that ARIMA that was created, and then it becomes the object that is inside of here, inside of that function. Yeah, so a good way to kind of integrate what Cliff was wondering about by talking about this, to then show that this whole thing becomes like the X value that then goes into here. And it just think of it as a pipe, like it's passing through, which is weird because you wouldn't think, don't I need inputs? It becomes the input for the next function along the path it goes through. So what's really great is you create this long sort of pipe, and then you want to change something early on. Like you've got this long thing that pipes through, then you could just change like a function or change what your input is at the start. and then everything just pipes through, and you get like the end output. Be like, okay, now I want to change what the ARIMA is. I want to add some seasonal differencing. Let's see if that helps this. And now we can see right here, we're doing a lot better. We might need to go season. We still got seasonal spikes. So we're seeing a large drop on the ACF on 2. So we're really only seeing the seasonal here. With the seasonal right here, the seasonal differencing looked to help some. We're seeing some larger variation right here. You see, I can change the lambda. Let's put the lambda to null. It's not going to look better like this, is it? No. We want that lambda on. That lambda's helping a whole bunch. So got to remember AP. So we're seeing, we need to look for this is an autoregressive 2, I think. Some statisticians yelling at me, no, that's an MA2. So we're seeing the drop on the ACF on the 2. So on the second season, no, that's the first season. What am I saying? This might be a 1-1 because we're seeing a drop right here on the ACF on the first, and it's negatively correlated, and the season is negatively correlated. So let me add in the seasonal ACF, and I wish I could see the partial. Oh, you know what it is? GGTS display. I don't care for that histogram. What? Is it mad because it wants a fit? Object list double. I hate it when it doesn't pass the object properly. Let's throw it through a forecast real quick. Does it want the forecast? It's mad. So I like check residuals better. GGTS display should play. Yeah. Okay, let's go ahead. You know what I can do? Okay, GGPACF. Don't fail me now, GGPACF. Really? The ARIMA's outputting a... Should not be able to get the forecast? Forecast. Oh, wait. I think the problem is in part. If you remember, I mentioned this earlier. The forecast package has its own forecast function. I think... No, it's not the issue. Why is it not... Let me go classic. I'm going to save my fit. We got the check residuals working. Put on all chill music while we diagnose the error right here. Check residuals, fit, works. GG time series display. So we got the different options right here. And you know what we need to put in it? I know we need to put in it. Our residuals. There we go. Okay. And now we can fix our code. If you can't tell, I'm used to the classic way of doing everything. I'm trying to orient myself to dplyr, but that's why I should teach people how to do things a certain way I want people to do things. All right. What? Wait a minute. Oh, because the residuals. Okay, I can get that. I know what it is. I don't like doing that. That should work. Is it not residuals out of that? Fit, $. Oh, it's lowercase residuals. There we go. Okay. Not my top way of doing this. So when I created this, which I don't need this save into anymore. When I created this, I only took the residuals out of it, and I passed the residuals as the object into the GGTS display. We are seeing decay in the PACF. If you look at, let me vanish while you look at this. We are seeing decay in the PACF on the lag 12. We're seeing a drop here on the seasonal lag 1. This is our seasonal lag right here, and this is our first initial lag. So let's go for the low-hanging fruit right here. So AP, so we should do it on the, AP, so the partial. So this is the moving average. I also get those confused. It's good to have those written down. Let's see if that helps out. Boom, gone. And we see the decay on the seasonality over here, and we see the drop right here, MA, so that's a moving average. And let's do it. Looking a lot better. Notice the differences right here for where we have moving average 1. We see the decay along here. We see the decay in the seasonality. where we see the sharp drop right here in the, it just goes down to like nothingness, but then the seasonality. So Cliff and everyone, is this making sense right here? It's very, you gotta look, you gotta remember, I remember MAAP. So if you see the sharp stop on the ACF, that's the moving average. If you see the sharp stop on the PACF, that's your autoregressive. So this ACF right here having a sharp stop right here is indication of a moving average 1. We don't really see it appear on the second one. All this looks like noise. Then in seasonality 1, going back a seasonal period, that's why I chose the seasonality right here. We're seeing this, and this is not the original. This is before I put in the moving average 1 for the order. Then this is where we still have the seasonality, and now you can really see the decay in the PACF. And this is where I decided to do the seasonality right here, and this is post-seasonality. We are still seeing a little something, more than I like. This is not horrible, but this is better. And we could see what the AutoArima does for us. The AutoArima kind of uses like a search grid. I'm trying to think what else might be good here. We've got a weird point down here, especially. Little weird point up here. That's an extreme. Something happened in the 93 or so region. It's 92, 93. It's worth investigating, and it kind of carries through. That's interesting. I don't know if that's a monthly difference right there. Let's see what AutoArima does. See what the search grid does. What we have right here. Did we beat AutoArima is the question. Always trying to beat that AutoArima. Does it give us residuals out of this? Same code. Thank you for using the same code. Let's use a little dplyr and pass that through. See if we look any better. And the answer is AutoArima is not really looking better. We probably want to throw a lambda. Let's give it the same lambda. So AutoArima, I'm guessing, will allow us to input a lambda right here. Lambda equals, let's throw an auto, see if it likes that. And the answer is, there's that, and there's this, and yeah. Did we get the same model? Did I just fit what AutoArima fit? Really? Here's our model, which I created, and here's what AutoArima creates. I am not joking. Wow, this kind of makes my day. Just okay, this made my day. Everybody. Do you see it? Gosh, that makes my day. Haven't worked this data set yet, but do you see it? Sydney, yeah, do you see it? This makes my day. Brian's top moment of the day. I've been reading that guy's time series book. Like, I've read the same chapter like 4 or 5 times. Really good time series book that we posted for our class by one of the top guys in time series. I mean, he literally writes the stuff we use. So, and what do you notice, Sydney? What happened when I went through this process right here by looking through my models? I'm sad we didn't beat AutoArima. I'm sad we did not beat AutoArima because there's no reason to compare what I did. Someone might say, well, how do you know you didn't beat AutoArima? So why is Brian not thinking he beat AutoArima? Because here's the answer to the question. Here's what I got. Here's what AutoArima got. And why? Just double checking. Why is the question moot for did Brian beat AutoArima? Who can answer why it's just no, there's no point in that looking into that. Because what did we get? Funny enough, the model we created here is exactly the same model that the AutoArima search function found for us. So we did what it kind of wanted us to do. I'm sad that we didn't beat it. I was really hoping we could beat it. I mean, we could try other things, but we went through, we looked for the seasonal components. We went through, we looked at the ACF, PACFs, and we narrowed it down to this model right here. So good stuff. Good stuff. We could try decomps and stuff like that on this. But overall, and you know what we could do? Let's go grab the code from today. Where were we working with today? Let's bring us back here. Let's look at the code today to finish this off. And maybe we'll try a little bit of new code, and then we'll take Trace's question here. What package is GLMnet? It's a method. It's a method inside of Caret. So it won't be a package. It'll be a method inside of Caret. Method equals quote GLMnet. Quote GLMnet. It'll look like, you'll see method and method name right there. So whenever you see GLMnet, GLMnet right here is going to be this. It's going to be your method inside of the train function. So the method inside of the train function. So GLMnet is like a thing we do. It's like if you go to McDonald's is like the function right here, and then getting a cheeseburger is at, I don't know. I just want McDonald's. Let's go ahead and take a look at this right here. And please ask more questions if you're stuck, I think. Awesome. Great job, Zaid. Okay, let's take our data. Let's see how we're doing. I thought it might look better as a piecewise. I was considering it as a piecewise. This is a good review of today-ish. So I was considering it as a piecewise function. We're just going to kind of use the code we've already written. Great stuff to do. Write some code, use that code again. We're going to take the gas function right here, pass it through. You know what we might need to do, though? Before we fit these models, we might want to do a lambda transformation on the gas. So what we can do right here is we can take, and we should be able to. These are going to fit the trends. Let's not do anything about. Unknown. No applicable method for model applied time series. Is it mad about that? Oh, wait. This is just taking the gas data set. Let me get the gas data set. It has different variables. There's the gas data set. And we are predicting gas. It doesn't really have a x variable, so we might need to use different methodologies on this. So, and these are taking tibbles, time series tibbles. Okay, let's first make it into a tibble. So a little bit different right here. Let's overwrite as.tibble. Let's call it gas2. Bad idea to overwrite what you have. As.tibble and tisble. There we go. And let's store gas into it. And there we go. There's the time series table. And we've got the value right there. Good. So we've got the index and the value. Okay, awesome. Let's go here to value. Like it. And we might be good. We might be able to run our code. We don't have those naughts, though. Let's look at our data again from the original. So we're just going to go to an auto plot. If I'm going to put naughts into this, where would you put naughts into this? And we'll do a lambda after this. If you were to put, we might try 2 piecewise, but I think I'm going to throw a naught down here at 1970. That might be all right. And I'm going to throw a naught over here in 1981. 1970, 1981 should work. So 1970, 1981 should work. Let's hope things don't break. So right there, good to go. Autoplus should work on this also now, right? Of course it works. It did work, right? It just said something was not specified. Okay, it worked. And fit trends, no applicable method use model. It's mad about the model function right now. Let's make sure our code is running from earlier today, that we don't have something conflicting. Marathon not found. Oh, don't do that. Okay, that is running. And what's it mad about here? It said no applicable. Maybe it's because we didn't load in everything yet. No applicable method applied to an object of class time series. Oh, because that. There we go. So this is the confusing thing, Sydney, which I'm just kind of doing some new-ish stuff right here. Yeah, good go. Awesome job right there. We'll see how our models look right here, see if anything good came out of this. And we've got our code from today also to take a look at how these worked. So let's go ahead and take a look at these right here to see if we got anything interesting out of this. Here's our whoa, look at those. Wow. Horrible residuals on that piecewise right there. Wow. And overall, our models, pretty good R squared's actually interesting. The exponential's doing a better job, but overall, these models are not doing that amazing. And let me see something real quick right here. Because I wonder if, well, I'll take a look at that later. Because it's dealing with the FPP3. Trace, I think we'll head over to your question. But wow, that is not good residuals. Truthfully, what we should probably be doing here is we should be able to take and go diff. Can that run it? Oh, I didn't do a pipe. The diff is not liking it. Should we pass through gas 2 on the diff? Oh, it's probably not taking the gas 2. It's taking the diff gas 2. It doesn't like that. That's the argument. That's the problem we're getting. It doesn't like that because it needs to take the variable. So this is why I don't use pipes, because all I have to do is go here to diff of gas 2, and in gas 2 we'd go to the value, and we go to 1, and there's the differences right there. So then getting this through to the pipe is the issue. It should be augment, actually, I think, but augment we need like the value, and that's where we have to get into more dplyr, but we want to take these differences. You know what we're going to do? Do one last thing right here, and then we'll check this out. We're going to take right here and store this, overwrite it. Hopefully that doesn't destroy. Oh, it's mad. It doesn't like that. Assigned data value must be compatible with existing data. It's mad about it. Existing has right here. Yeah, it doesn't like using this. Right. Oh, wait. Value. Still doesn't like it. Might have differenced it twice. We'll worry about that later. That's the issues with dplyr, and that's the things I'm going to look at. That's why when I saw this, I was like, this is a major change. But going through here, we would probably need to difference this right here because we're seeing not the best of models. This, no. And the differencing really comes into play right here. And this is what we saw with the model earlier. Hence, we have not done enough differencing. And we're seeing the interesting nature of our residuals for the piecewise components. I am interested in that piecewise model. But let's go ahead and look at Trace's question right here. Trace had a question. So that's a good review of time series right there, going through, looking at some piecewise models. Trace was wondering about, could you go over 2i for 474? I think neither model is preferable, but it's asking which model would you prefer. So 2i, don't want to quite give away all the answers yet. So 2i, start here. Let's go look at 2i. So when we look at 2i right here, what should we do for our models? So Trace, what should we do for our models? We want to compare the what of our models when you look at your two models. So I don't want to give away quite the answer. I don't want to say it yet. But talking about 2i right here, the ROCs and the standard deviations. Yep. And that's what we're talking about a lot today, is that the ROC is the ability for the model to correctly give the yes class a higher probability than the no class. The percent of the time it does that. So you want higher ROCs. Higher ROC is better. But the standard deviation is basically your what in the ROC. Your standard deviation is basically your what in your ROC. Like when you think about the standard deviation of your ROC, it's basically like your this in the ROC. Like, what am I trying to tell you by saying your standard deviation is this in your ROC? Would you like it to be small? It's your amount of this. It's like your plus or minus, your uncertainty. I like that right there. It's like your plus or minus your uncertainty, because you're saying, here's some hints. I think we rank things correctly about 66% of the time, but plus or minus like 1%. Like I'm uncertain that, you know, like 66 is my guess about how well we do. And then what do you notice? Maybe your ROCs are within, kind of give some hints towards this in class today. When you're looking at if your ROCs are really that different, you could like standardize it or look at your larger of the two standard deviations, like the last homework assignment, and then talk about like how close are these ROCs to each other? Are the ROCs pretty far apart? Or are they pretty close together? So that's what we really want to look at right there. Are the ROCs really close together or really far apart? We need some sort of metric here to look at this. We need some sort of, you know, standard deviation to talk about these differences to see if the differences are small or if the differences are large. Does that make sense, Trace, right there? I think I'm basically telling you, take your two ROCs, divide by the larger of the two standard deviations. Which you should, when you look at the two ROCs for it, you're like, oh, those are I mean, I'm not saying what they are, but you look at me, you're like, oh, those are, looking at those right there, those are, I don't want to say. Yeah, exactly. That's it right there. Exactly. That will give you a standardized, so that's Trace right there. Perfect answer. Let's throw some 50 points. That's exactly what we're talking about. Like, I don't want to say answer what. ROC is just an estimate. Exactly. It's an estimate, and then any estimate would have uncertainty. It's like your friend says to you, I'll be to your house at 5 p.m., and they get there at 4:59. You said, you'd be here at 5. You're here at 4:59. They're like, well, sometimes I'm plus or minus 5 minutes. Sometimes I'm a little early. Sometimes I'm a little late. So the next day they get there at 5:03, and you're like, you said you'd be here at 5. And they said, but I could be off by about 5 minutes. And then the next day they get there at 4:54, and you're like, but you said you could be off by about 5. And you're saying, yeah, I could be off by about 5. 5 is the amount of uncertainty I have. It's not saying I will be off by 5. It's saying, like, imagine if I say, let's go out to dinner, it'll be about $20, but I could be off by about $1. When would you, and don't be too exact, I know, because you might go for this. When would you start to question my estimate of dinner will cost $20? If I say dinner will cost $20, but I could be off by about $1, when would you start to question my ability to tell you how much dinner costs? I said, let's go grab some dinner. It'll be about $20. It'll be a nice, good steak, not like a filet, but maybe a good, like, sirloin with potato and salad, like pretty good, nice meal. It's going to be about $20 with tip. So tip and everything included, drink, tip, everything. There's a dessert too. So pretty nice meal, $20. Not bad. Not super fine dining, but not McDonald's. When would you start to question my estimate? Yeah, and then they're basically identical. That means, like, they're virtually identical at that point. It's like, yeah, they're really the same model. I mean, they have no real difference. That's like when dinner costs, for this example right here, Trace, that's when dinner costs $20 and like 2 cents. And my friend's like, but you said dinner would cost $20. And I'm like, yeah, it cost $20 and 2 cents. I could be off by about $1. I was off by 2 cents. Actually, it's more like 1 cent. When you said dessert, that's when you were in, Zaid. In actuality, it would be, to make the example perfect, Trace, it would be dinner would cost this amount right here when I say I could be off by about $1. But what if dinner costed $28? Then I told you I could be off by about $1. We go out and we get dinner and it costs $28. And you're like, $28. Yeah, then you'd start to be like, wait a minute. You said you could be off by about $1. But what if I told you dinner could be $20, but I could be off by about $10? Do you see why the amount of uncertainty matters in this conversation? Like, if I tell you it could be $20, but I could be off by about 10, well, then 28 doesn't seem that far away. If I tell you it could cost $20, but I could be off by about $1, 28's ridiculous. You'd be like, you said you could be off by about $1, and it cost $28. Well, you're really far off. But if I tell you 20, but I could be off by $10, now 28 would have a z-score of 0.8, and it's not that far away from 20, because we have to standardize that distance of how far two things are away to talk about, is this really a big difference? And that's what the standard deviation does for us. It lets us understand, is this difference between the two numbers, which is just numbers, so what does the difference mean? The difference has to be held to a metric that will then tell us this difference is actually rather large or small. So when I tell you the dinner will cost $20 with a standard deviation of 1 and it costs 28, that's a z-score of 8, and that's super weird. You're like, you lied to me, you were wrong. But when I tell you the dinner will cost $20 with a much larger standard deviation of 10, now 28 is 0.8 standard deviations away, and that's rather small. You'd be like, well, he did tell me that he was pretty uncertain of how much dinner would cost. Think of it. It could cost $20. It will cost $20, but I could be off by about $10. You're like, wow, you're pretty uncertain on how much dinner will cost. And when it costs $28, you're like, well, it's not that shocking. He was $20 plus or minus 10. Not exactly plus or minus, because if it's 31, you're not going to be like, what, you said it'd be off by about 10. I'd be like, well, about 10. Is this making sense, Zaid and Trace, right here when we talk about what standard deviations mean? And they're just more or less uncertainty in our estimate of what we're creating. So when I tell you the AUC is about 66, but I could be off by about 0.1 or so, I'm telling you I've got a pretty good understanding of what the AUC should be. Yep. So you just want to be thinking about that. Like, you always want to bring these concepts to the real world. You don't want to be like, like, our model's predicted accuracy on a holdout sample of 0.4% of the data. But I mean, I don't know. We try to make it a business analytics question, Do you have any time to go over 1D and 474? Yeah, is this on the current? I think we can take a quick look at that. It's on the current assignment. Do I have that up? 1D. What's 1D say? I've given some hints here for this one. Let me drop some hints. 1C, I know we have done this, but I do not get the check for 0.75. We'll do 1C, and I'll give some hints for another one. Question, sorry, in here on... Yeah, so use the number currently in there, and you should get the current sanity checks. I've told the grader to be very nice on this. Sorry, they're called the insanity checks today. But use the current numbers, and if you feel like the grader was mean to you, just tell me. I promise they're a very nice grader. But tell me, and we will do that right here. So I'm going to do this for a different data set right here. So let's take a look. I'm going to do it for a much smaller data set. Let's go take a look at this. No, sorry. Every once in a while, I throw in some insanity checks to keep you on your toes. Okay, this is a totally different way of doing this question. So we can do it a different way here today. And you're welcome. Let's go here and make a data frame. This is a totally different way of doing this. Like, be very careful. Brian is doing a very different question he is making up. Okay, so I'm going to make a data frame. Sure, let's make a data frame. And the data frame is going to have inside of it, class. This is what something actually is. The class is going to be equal to the vector of yes, we'll just call it y, no, yes, yes, no. Much smaller data set than what we're doing here. Let's put a second vector inside of it. Second vector is going to be probability. And the probability right here is going to be equal to the vector of, we're just going to put it in order for the nicety of it, 0.98, 0.80, 0.60, 0.40, 0.10. Is that 5? 1, 2, 3, 4, 5. We got it. Okay, let's take a look at the data frame we created. And there is the data frame we created. Is that making sense what I've created right here? Now, when we look at the AUC of this, does anyone know the AUC off the top of their head? I will throw 400 points if anyone knows the AUC of this off the top of their head. I'm taking a moment to figure it out. You have to figure out in the next 30 seconds. 400 points. Crazy points on the line right here. My brain's slowing down as I'm trying to think through this. Okay, I got it. Who knows the AUC? Running out of time. What is the AUC of this? Good review question from today. The skeleton, you are right, Taylor. You are right, Taylor. Oh, does anyone know the AUC? I'll take 100 points for a good guess. Does anyone know the AUC of this? Oh, no. I'm going to throw 100 points. I offered huge mega points. Always feel free to take a guess. Do not worry. You might get lucky. I believe the AUC of it is... Oh, close, Trace. I'm throwing another 100 points. Trace taking guess right there. Zaid right there. Zaid earned everyone the extra points right there. Zaid, you are correct. Zaid following the... Yep, Zaid, I think that is correct. I'm pretty sure it is 4/6. If you look right here, this yes class is properly ranked 2 out of 2 times. This one is 1 out of 2, 1 out of 2. That's 4 out of 6 total. And so it is 66% AUC. So excellent work right there. Some huge mega points in that moment. Saeed, great job. Showing just knowing how to calculate AUC, which is what this is doing. Yep, that's good practice. I like throwing some practice questions out there. So just great job. You got it. I was saying the answer, but I'm in the future. So I was like, I'm pretty sure. So awesome work right there. You got at the last moment. Huge points right there. Great job. So if you want to think about when things are ranked correctly, I am doing this very different than yours. This is an example. It's very different. I'm going to subset my data frame on the variable class equals logical check to capital Y. That's the yes class. And now we're going to subset on the no class. This is very... Oops. Okay. Should look at what we've created. It is there. It is there. We're good to go. Now, the percent of time we are correct. I just want you to think about this right here. We are going to compare this first observation. Let's go grab it. Who can tell me how to get this first observation? We're on a roll today right here. Who can now tell me how to get this first observation right here? Who can tell me how to get this first observation? I only want that first observation. Be very careful. I just want this number right here. It's inside of here. You can just put the extra little bit on the end of it. So I only want that first. Close. Do remember it's a two-dimensional object. Taylor right there, 50 points. Taylor, great job. Once again, people just helping out, throwing in answers. Take a shot. It's a two-dimensional data frame, though. It's two-dimensional, or data frame, i.e. two-dimensional. So since it's two-dimensional, we want, let's double check. Always got to check. Row 1, column 2, and then make sure you got the right thing. See, I can't even do it. And we get the value right there. Does that make sense? Great job, Aaron. Yep. Row 1, column 2, because it's two-dimensional. And so we're just going to row 1, column 2 for the yes data frame, and that's the value. Now, the goal will be to check it against all values in what? We want to see if it's greater than. It says less than, but we can do greater than. It just depends if we put the no class over here. The no class would be less than, or it should be greater than the no class. We want to go to where? You could do it via a vector if you wanted. So you could do it as a vector right here. We want it greater than, has a higher probability than the no class probability. And look at that. And if we go right here and do the mean of this, guess what we just found out? We didn't find out anything is what we found out. There we go. Now we found out something. Now the percent of time the yes class gets a higher probability than the no class for the first observation, which is this one, is 100% of the time. What percent of the time is this value higher than these values here? What percent of the time is this value that I have currently on the screen higher than these values right here? This value right here, and I'll show you by doing it. The second row, which is this value, what percent of the time is it higher right there? What percent of the time is that value higher than these values? You're looking at this and you're saying, is it higher than this? Is it higher than this? What percent of the time is it higher than? What percent of the time is that 60% higher than the two values right here? We got two values. 50%. Great job, Lauren, right there. 50 points right there. Just going crazy. It's Wacky Wednesdays. It's really Wednesday, I promise you. You think it's Tuesday? It's Wednesday. It's always Wacky Wednesday. Wacky Wednesdays. What percent of the time? It's the same deal for this other value right here, that this is higher 50% of the time. NaN. Oh, I went to the third column. Oops. Third row. There we go. Not a number is what we got right there with NaN. So when you look at these right here, what you're actually doing is you're actually doing a weighted average of these. You've done 3 repeats of this. And remember what Zaid and I were saying is there's the answer. So the yes class has a higher probability than the no class, 66.66% of the time. But we can figure this out. And if you notice, it was said a moment ago that this is our skeleton. We just made our skeleton right here. So we can store it into an object. And let's go here and store into the first position. And that is our first position 1. And we could store into the second position. And do you see what's happening right here? It's as though this is going to be the placeholder. Taylor, do you see where the I is going to go? As in what's going to change? Like I just ran the for loop right here. Oh, maybe I got a previous answer. Let me remove that. That's a combination of the correct answer from, yeah. Okay, so let's restart it. You can check some numbers there if you want. And then here's the second. And then here's the third iteration. And this is for my smaller data set. This is not yours. And then there's the answer. Taylor's seeing it now. Yeah, like if you watch what I'm doing with the for loop, you're like, oh, it makes sense. I see where the eyes are going to go. Like, it's like, okay. And then we're going to go through the length of it. So I think Taylor, you got it 100% right now. I think Taylor saw it as we were doing that right there. Great job, Taylor. It's tricky. You just got to be like, okay, where does the I go? What's going to change? I think I got it. Yeah. Just kind of look back right here. I think these are some of the correct numbers. These are wrong numbers because I overwrote them, but you've got the end of the vector. If you're getting this right here, great job. And if you're feeling like you got it wrong, just let me know. These are wrong numbers because I overwrote them from my loop. But any last questions? I think this should, I don't want to quite do the for loop. It's kind of set up for you here. You know? So we kind of got the skeleton right here, and then you're going through I, and then I think it, Taylor, you kind of saw where I was talking about, the eyes would be, don't know. That's always going to be the second. You could change this right here. That'd be a fine way to do it. If you want to only use one placeholder now, and now you're going to get the same values. So you could do the following, and you'll get the same. We just overwrote the values, but it worked. So you could do that right there, pulling the column out of it instead of using it as a data frame, taking 2 dimensions. But I think that's got it. I think people are able to solve this one now, and they kind of know a jumping off point. Remember, I was trying to get to that point where you're like, I see it. I see it. And I think that gets us to that point with this one where people can see the answer. And we're about to head out. Oh my gosh. 48 hours will be done. Ah! Oh, wait. We'll go back here. I don't even know buttons I'm hitting. Oh my gosh. Crazy summer. Well, if you have questions, email me. I'm going to go look at the Discord and the emails, make sure everyone's on track. I'm going to go probably take a walk, get some exercise, eat some more lunch. Woo! Busy times. Thank you, everyone, for all your hard work. Swinging by office hours. It's really one of those things, and everyone knows this. And then I'll see you again in the fall. Aaron, what are you taking? Aaron, what are you taking? Are you taking time series? Any BAS electives? So I teach right now. Oh my gosh, the fall's going to be half as crazy as the summer, I hope. The fall, I'm teaching 201, 320, 474, 475, and then my 475, I think, has the graduate component. So I'm technically 475. Awesome. Well, you got to see some of that today in today's office hours. We're making some improvements to it too. I think it's good. I'm hoping the reviews come back good on it. Not saying give me good reviews, but I like good reviews. I like positive criticism. If you have things you don't like, and you can be like, you know, Brian, you can be like, I hated the course, and here's what you need to improve. As long as you give good advice on what to improve. If you say you hated the course and that's it, well, that doesn't really help me make the course better. But we're looking for some ways to add on what's going on. I'm taking 340. Yeah. 340 is excellent. I think 340 is Charlie Quick, right? Do your shiny data camp. Yeah, that's what we should do, right, Lauren? I think we should do dplyr the first week, and then we should do shiny data camp the second week. If anyone put them in your TN voice, your advice for the course, you are going to drastically control the way this course goes. If all of TN voice is like, I hate shiny should not be a part of this course, it'll go away. If the TN voice says things like, I like shiny, but I wish I knew more, then we're definitely doing shiny data camp. I always read the TN voice. I read everything. Charlie Quick is awesome. Yeah, he's a pro. So I totally agree. We saw some really cool stuff with shiny. To think that these things can be done inside of R. Let's play it one more time. For those who haven't seen it, let's go grab that. Where is it? Okay, here we go. Oh, it already passed. Okay. So we found out today, this is our last little bit right here. Let's go to it. We found out today that there is a contest for the best shiny apps. And unfortunately it passed. We're gonna have to wait till like spring next year. So maybe I'll get my students up to par on this. But you can go and look at some of the past winners right here. And so let's go look at those past winners. Here's the shiny user showcase of past winners. And we got to see a lot of really cool stuff today, but there's some Pokemon ones, so you know where we're going right now. We failed previously at having it guess our Pokemon because Brian thought the Pokemon had a Mega Evolution. We got MRI stuff in here. The MRI one is pretty insane. Pokemon 20 questions. Let's go ahead and view the app right here. This is all being done via R right here. So there's your please wait as your shiny app loads. Okay, so what Pokemon are we going to think about? I need a Pokemon in the chat. Name your Pokemon. And then we're going to have to go look it up on Bulbapedia to answer some of these questions, unless we're doing like a Weedle. I can tell you how tall Weedle is. Maybe we should do Weedle. So pick your favorite Pokemon. I'm going to go to Bulbapedia. For those who don't know Bulbapedia, Bulbapedia is your number 1 source for Pokemon info. I like how we're using shiny apps. We could talk about Piplup. Piplup is... I should know Piplup. Piplup is not too later of a gen. So search Bulbapedia, Piplup. Why am I not thinking of Piplup right away? So, oh, it's the penguin. It's a starter for the gen. That's a starter Pokemon, Piplup. So, Genshin Impact. Anime game. Oh, whoa. My screen just went out. Oh, that's not good. Well, it's back now. Oh, I don't like that when screen just randomly blanks, don't I? Arceus, why am I not thinking of Arceus Pokemon? Oh, dude, that's a legendary, is it? No wonder it is a later gen legendary. Yeah, I don't know. So which one we should do? Piplup or Arceus? I don't think I have an Arceus on Pokemon Go. I don't know if I don't have it in Pokemon Go. Piplup or Arceus? We need a deciding vote right here. I don't think I have an Arceus. That must not have been released yet. What gen is it? Gen 4? Why is not Arceus not released in Pokemon Go? I have an Arcanine, of course. I do not have an Arceus. I do not know if they've released Arceus yet. No wonder I don't know its name. I was like, Arceus? Is that shiny? I gotta look to see something shiny. Do Piplup. Let's do Piplup. I'm guessing Piplup is not taller than a meter. Oh, well, not taller than a meter. Piplup is not taller than a meter. I can't believe do Arceus way cooler. So Taylor says do Arceus. Okay, let's do Arceus. Legendary Pokemon Arceus. Normal type. Ooh, interesting. A normal Pokemon right there. Normal type Pokemon. Definitely 3.2 meters tall. A little bit taller than me. That's a cool looking Pokemon. Okay. Is it taller than 1 meter? Yes. It's taller than 1.4 meters? It really just wants to know. Not a dual type. Just normal type. Only normal. Gotta learn my Pokemon. Is it an electric type? No, it's normal type. It's going to listen to me on the microphone right here. It's really thinking right now. Does the Pokemon evolve from another? No, not including Megas. Legendaries, I don't know of any legendaries that have evolutions, so please tell me if I'm wrong on this. Legendaries don't have evolutions usually, so I'm saying no. So be like, Brian, you messed up. Ah! So I'm saying that's totally not. Is it a bug type? No. Wait, is a bug type not very effective? Oh, I don't know my types. What is good against normal? Is bug type not effective against it? Oh, man. I'm so bad at type matchups. I just pull out my massive legendaries. Does anyone know this? What is bug against normal? I do not know the answer. Yes, no, not sure. You could look up a type map real quick. I can't tell you if bug is effective against normal. I think a lot of things are... I might put not sure, but it would help if we gave it the real answer. Let me see here. Normal type match Pokemon. And normal, weak against, strong against. That's talking about bug type. We need bug. Bug is where? Where's bug? They make these huge grids for these things. Okay, wait, here we go. Bug is normal. Wait, bug is weak against... Okay, no, the answer is no. That was a hard one to answer. The reference table doesn't say, I don't think. We'll go take a look at the reference table here in a second. They do apply that reference table. Is it lighter than that? What should it say if it's effective? Yeah, we have to zoom out a little bit here. We might actually be able to get it's effective or something off of that. Is it lighter than 1 point? That's pretty heavy. Is it? Weight, 320 kilograms. No. No, it's Gen 4. Is the ice attack not very effective? Oh my god. Stupid. Ice is no. You're gonna lose game. Nope, not Groudon. Oh, that's a bummer. Oh, let's just do a Pidgey. No. Have an evolution. Yes. Pidgeys have evolutions. I wanted to guess it right. I'm really bummed. This app should not be a winner if it can't guess my Pokemon. Did I mess it up? Is the color of your Pokemon primarily red? No, it's like yellow. Is the Pokemon come from the bug egg family? No. It's not a bug. Is the color of Pokemon primarily gray? No, it's a Pidgey. Is it a baby Pokemon? No, it's a Pidgey. Is it a dual? Pidgey's just flying, right? No, it's normal flying. Okay, yeah, it's dual. Is the Pokemon in the first stage of its evolution? Yes, Pidgey is. Is the Pokemon a grass type? No, it's not a grass type. Is the color Pokemon black? No. Did the Pokemon first appear in the following generations? No, it's a Gen 1. Come on, you can do it. Is it dark type? No. Is it smaller? I don't know Pidgey's height. Yes, it is. Oh, I think it's going to do it. I just said yes. Is a dark type attack super effective on this Pokemon? Okay, so we have to go here. Flying. It's flying normal. No, dark type is super effective against ghost and psychic, so no. It's not a water type, it's a Pidgey. Heavier than 2 point, heavier 1.8 kilograms. No. Does the Pokemon come from a flying egg? Whoa. 1 point, not sure. Yes. I don't like this app. I was thinking about just ending the stream right here. Like, I don't like this app anymore. You're not good at guessing my Pokemon app. You're very bad at it. I am bummed. I'm better at guessing models, Arima models, than this is at guessing Pokemon. Could you not have just made a guess? You literally narrowed it down to a very small flying Pokemon. I could guess this Pokemon. I know, Aaron, right? Like, a very small flying Pokemon that is the first non-evolved. What else did we give it that was super obvious? Like, super small, flying, dual type Pokemon. I mean, you've got like Swablu, but that's not Gen 1. Did it ask if it was Gen 1? If it asked if it's Gen 1, it's ridiculous because knowing it's Gen 1, Spearow is I think Spearow is going to be bigger. Spearow, I think, is the only other Pokemon, and maybe the Spearow is about the same size. So, yeah, you think it would because a lot of people are going to know that. Spearow is the only. What's another flying Gen 1? Zubat, but Zubat might be a dual type. Is Zubat like flying poison? And Spearow might not be dual type. Oh, it's normal flying. And then Zubat. Any other flying Gen 1? Can anyone think of any? And that's flying poison. I was sorry about that. Can anyone think of any other flying Gen 1? This is the real questions. Pidgey, Zubat, Spearow. I can't think of any. And then, of course, but it's not going to be Zapdos or Moltres or Zapdos, Moltres, or Articuno. Those are Gen 1, right? Yeah, the birds are Gen 1. The dogs are Gen 2. Legendary Pokemon, for those wondering. I mean, people were really wondering what we're talking about right there. I can't think of any other flying Gen 1s. I feel like there's one more. Butterfree. And then, of course, we're going to have not only Butterfree, but because Butterfree comes from Caterpie. And then we have Weedle, which Weedle's going to turn into... Oh, my God. Why can't I think of the Weedle evolution? Oh, my brain is just... Oh, no. So we got Butterfree. And then Weedle is going to turn into... Because Butterfree comes from Caterpie. Weedle... Oh, man, that's bad. Oh, it turns into Beedrill. Weedle turns into Beedrill. So Beedrill's flying. Butterfree is flying. So, yeah. Okay, there's a good bit of flying in Gen 1. Man, it's so interesting going back to Gen 1. Couldn't think of Beedrill for a second. Well, this was all done via Shiny, though. So what's really cool is if you really want to take a look at this, you can view the code. And we're going to go here, download the code. We'll just take a look at the code here a second. Maybe you can make this better. Hey, if you were mad about this app right here, and you said, this app is just not cool, I'm going to go here. I'm probably just going to overwrite one of my servers that I've got. It's taking a while to unzip. Well, actually might be a big file. Let's take a look at their files right here. I'm going to close down R. And let's take a look. I am interested in how they wrote this. The server's where it's really going to do the computations. So let's get this pulled up. Okay. So here is, we need package recoder, which I do not know what recoder does. Let's just grab it. Function, input, output session. They're holding session. PokeReact, reactive values. Looks like these different values right here that they're taking. And then they're rendering text. This is actually not that complicated. Everything we saw going on right there in the server side was all done via 144 lines of code, where they ask the different questions, it looks like, and they try to narrow it down. Maybe they could have written a little more code. Unable to guess Pokemon, you win. Did it give me a win? There you go. There's everything going on in the background of the app. Cool stuff right here. You can go ahead and take a look. I would have figured it was much more complex too. I'm rather shocked that it's done in this little lines of code. We'll take a look at the UI real quick, because I've never seen a UI look like with the way they had the UI. Oh wait, there's more files. And they've got a data pull. I've never seen this data pull object. Okay, so let's take a look what they got. They're going to a GitHub for the Pokemon, the languages, the names, the base. So they're grabbing all of this right here from a CSV file online. So if you look right here, they're using fread, which is a way to fast read tables. They're using the fread to take all these right here. They're using it as their data pull right here. Shiny semantic. Why not? Let's install more packages. Their UI is not that complicated either. But yeah, we should be able to locally run this right now as long as we have everything. Let's go ahead and try to locally run this. It looks to be running. An error has occurred. Could not find function Uni menu. We'd have to see why that's not running. Let's go over here to this screen real quick and check this. Uni menu in R. This is a function in Shiny Symmetric. Did they not call Shiny Symmetric? Did Shiny Symmetric not load? Well, we're supposed to have that function now. Unimetric. If I could spell it. Or not. UI menu. It's called UI menu. It's not loading. I think Shiny Symmetric didn't install properly. No install packages. Nope. We might need to do some resetting. It's not taking it. This is supposed to be in Shiny Symmetric. So we're seeing some sorts of issues right here. We'll have to debug it. Really a bummer. I was wanting to run it here locally and see what we got. But yeah, I find this all to be interesting. I do not know what a UI menu does. It's in Shiny Symmetric. I don't know the Shiny Symmetric package yet, but I'd have to take a look. And they're using UI menu right here. So this is, just controlling the UI menu. Some sort of options right here. We're doing menu header, menu items, and doing UI icons right here for certain things. So this is just creating where we've seen with some people's apps, the different icons they're doing. And it's supposed to work. We could grab this example right here, not run. I hate when people do that. But that's got it. We'll check back here, but lots of fun stuff. All these different things you can do with Shiny. I'm headed off here, answer some emails. Be back later, everybody. Bye for now. Bye, Aaron. Bye, Lauren. Bye, Taylor. Bye.